In 1974, a team of scientists and engineers at the Arecibo Observatory in Puerto Rico sent a powerful radio signal to a distant star cluster, hoping to communicate with any potential extraterrestrial civilizations. This was the first and only intentional interstellar message ever transmitted by humanity, and it became known as the Arecibo Message. But what was the scientific purpose and significance of this ambitious project? How did it showcase the power and limitations of radio astronomy? What technical challenges and innovations did it involve? How did it advance our understanding of the galaxy and the search for life? In this article, we will explore these questions and more, as we dive into the scientific factor of the Arecibo Message. Radio astronomy is the study of celestial objects and phenomena using radio waves, which are a form of electromagnetic radiation. Radio waves have many advantages over other types of radiation, such as visible light, for astronomical observations. For example, radio waves can penetrate clouds, dust, and gas that obscure optical telescopes. Radio waves can also reveal information that is invisible to the eye, such as magnetic fields, molecular structures, and thermal emissions. However, radio astronomy also has some limitations. One of them is the inverse square law, which states that the intensity of a signal decreases proportionally to the square of the distance from the source. This means that radio signals from distant sources are very weak and hard to detect. Another limitation is interference from natural and artificial sources on Earth and in space, such as lightning, satellites, and radio stations. These sources can drown out or distort the signals from astronomical objects. The Arecibo Message was an attempt to overcome these limitations and demonstrate the power of radio astronomy. By using a large dish antenna, 305 meters in diameter, and a powerful transmitter, 1 megawatt, the Arecibo team was able to send a strong and focused signal to a specific target, the globular star cluster M13, which is about 25,000 light-years away from Earth. The message consisted of 1,679 binary digits, zeros and ones, which encoded basic information about humans, Earth, and the Arecibo telescope. The message was modulated by shifting the frequency of the carrier wave between two values, creating a simple binary code. The Arecibo Message was designed to be easily decoded by any intelligent receiver with basic knowledge of mathematics and science. The message was divided into 7 parts, the numbers from 1 to 10, the atomic numbers of hydrogen, carbon, nitrogen, oxygen, and phosphorus, the elements that make up DNA, a formula for DNA, a graphic representation of a human figure and its height, a graphic representation of the solar system and Earth's position in it, a graphic representation of the Arecibo telescope and its diameter, and finally a large number that indicates how often the message repeats, once every 169 seconds. The message was transmitted for 3 minutes at a frequency of 2,380 MHz, which corresponds to a wavelength of 12.6 centimeters. This wavelength was chosen because it is close to one of the natural emission lines of hydrogen, the most abundant element in the universe, which is at 21 centimeters. The idea was that any civilization interested in radio astronomy would be monitoring this frequency range. The Arecibo Message was not only a scientific experiment but also a technical feat. It involved several challenges and innovations that pushed the boundaries of radio engineering at the time. One of the challenges was to design a message that could be transmitted by shifting the frequency of a single carrier wave. This method was chosen because it was simpler and more reliable than using multiple carrier waves or modulating the amplitude or phase of the wave. However, this method also required precise timing and synchronization between the transmitter and the antenna. The transmitter had to switch between two frequencies at a rate of 10 times per second, while the antenna had to rotate at a speed of 1 degree per second to track the target star cluster. Another challenge was to create a binary code that could be easily decoded by any intelligent receiver. The code had to be simple enough to be understood by anyone with basic knowledge of mathematics and science, but also complex enough to convey meaningful information about humans, Earth, and the Arecibo telescope. The code also had to be robust enough to withstand noise and distortion during transmission and reception. To achieve these goals, the Arecibo team used several clever tricks. For example, they used prime numbers, numbers that are only divisible by themselves and 1, to structure the message. The message consisted of 1679 bits because 1679 is equal to 23 times 73, two prime numbers. This means that there is only one way to arrange the bits into a rectangular grid, 23 rows by 73 columns, or 73 rows by 23 columns. The receiver would have to figure out which orientation is correct by looking for patterns and symmetries in the grid. Another trick was to use redundancy and repetition to enhance the clarity and accuracy of the message. For example, the numbers from 1 to 10 were encoded twice, using two different methods, one based on binary arithmetic and one based on positional notation. The atomic numbers of the elements that make up DNA were also encoded twice, using two different scales, one based on the number of protons and one based on the number of electrons. The graphic representations of the human figure, the solar system, and the Arecibo telescope were also repeated several times, with slight variations, to show different aspects and dimensions of the objects. The Arecibo message was a remarkable example of how to design a message that could be transmitted and received by radio waves, using simple but ingenious techniques. The Arecibo message was not only a technical achievement but also a scientific milestone. It was a bold attempt to reach out to other intelligent beings in the galaxy and share some basic information about ourselves and our planet. It was also a way to test our own capabilities and limitations as radio astronomers and communicators. The Arecibo message was part of a larger project called SETI, Search for Extraterrestrial Intelligence, which is an ongoing effort to detect and decipher signals from other civilizations in the galaxy. SETI uses radio telescopes and other instruments to scan the sky for any signs of artificial radio emissions that could indicate the presence of intelligence. SETI also explores the possible nature and characteristics of such signals, such as their frequency, modulation, content, and origin. The Arecibo message was one of the first and most famous examples of active SETI, which is the strategy of sending messages to potential receivers, rather than just listening for them. Active SETI is controversial because it involves revealing our existence and location to unknown entities, which could pose risks or benefits for humanity. Some argue that active SETI is a waste of time and resources because it is unlikely that anyone will receive or respond to our messages, given the vast distances and timescales involved in interstellar communication. Others argue that active SETI is a noble and worthwhile endeavor because it expresses our curiosity and optimism about finding other forms of life in the universe. The Arecibo message was a symbolic gesture that showed our willingness and ability to communicate with other intelligences. It also stimulated our imagination and curiosity about what kind of messages we might receive from them if they exist. The Arecibo message was a way to expand our horizons and challenge our assumptions about ourselves and our place in the cosmos.